So as I've finished the array implementation of stacks, I'll be moving on to the array implementation of queues. So the queue is again an ADT, an abstract data type. Now the only difference between a stack and a queue is that a queue works with the property of first in, first out, which means that the data entered first will be removed first, and the data entered last will be removed last. Whereas as far as stack is concerned, the data that enters first will be removed last, the data that entered last will be removed first. So queue is basically first in, first out. Now in queue there's another difference. There are two pointers which have been used. One is the head pointer and another one is the tail pointer. So as I enter the values into the queue, now let's see what happens to these two pointers. Now if you can see, there are two pointers, as I said, head and the tail. Now for enqueuing, that is for entering the values into the queue, the tail pointer is being used. Whereas for dequeuing, that is removing the values from the queue, the head pointer is being removed. So this is to be understood. So when you want to enter a value, you use the tail pointer, and when you want to remove a value from the queue, you use the head pointer. Now when I click on dequeue, the head pointer's value becomes 1, and the first value, which was 54, that gets dequeued or removed from the queue. Now if I click on dequeue again, you can see that the head pointer and the tail pointer's value becomes exactly the same. Now if I dequeue, it will not occur because the head pointer's value and the tail pointer's value are the same, which means the queue is basically empty. Now I've clicked on clear queue, that is, the head pointer's value has become 0 and the tail pointer's value has also become 0. So let me perform some basic actions to this queue. So I'll be entering a few values now. Now you can see I have entered 5 values, right? Now let me dequeue this queue for 5 times. So I'm going to click dequeue 5 times, and accordingly the values are going to be removed from the queue. Now again, the head pointers and the tail pointers value are the same. So now what happens when I enqueue on a value onto the queue? That is, I enter a value inside the queue. This means that the value which is being enqueued, the position of that value in the queue only depends on the tail pointer. So even if the queue is entirely empty, only according to the value of the tail pointer will your value be enqueued inside this queue. So when I dequeue it again, the head pointer's value gets incremented, and automatically the value which I entered, which was 65, that gets dequeued or removed from the queue. Yeah, so that's about it for the array implementation of queues.